Okay, so from this segment, we're going to start Unit 4, which deals mainly with memory. We're going to be looking at various concepts related to memory and what role the operating system plays in making things function smoothly with respect to the memory, how the memory is accessed, how memory is allocated, and so on and so forth. So, any function that happens in a computer is guided and directed by the operating system, be it scheduling, be it process synchronization, anything. This is something we are very familiar with by now. So, the memory, of course, is an important part of the computer, the system, which is where all your data is stored. And if you don't have the memory, or if the memory is not, if everything pertaining to the memory does not function smoothly, then your computer is not going to work properly, and that's going to be serious trouble. So the various tasks which the operating system performs in the context of memory management are an important set of activities, which is why we are going to spend this entire unit looking at those concepts, right? So this is mostly going to be a theoretical unit. So if you looked at your previous two units, you had scheduling where it was a little bit of numerical kind of a thing, and then in the previous unit when you have deadlocks, deadlock avoidance, deadlock prevention, this that, there's a little bit of logical algorithmic thinking involved. In that sense, this unit might seem like a bunch of theoretical topics, not all of which are very properly connected to each other. So you might feel like some of the topics we look at are very disjoint. But yeah, that is the nature of this unit, and when we've covered some ground, you'll be able to connect the dots and make sense of things better. So as of now, we're going to be looking at a bunch of topics which might not necessarily lead from one to another in a sequential fashion. So yeah, with that intro, I think we'll start. So we're going to start with something we are familiar with from our first unit. Each process has a separate address space. Address space is nothing but the range of valid memory addresses which it can access. So memory addresses, all of you I'm sure have taken up the computer organization course, and you are by now familiar with the idea that your computer memory is identified by unique locations called memory addresses. And in our first unit in operating systems, we also studied that every process has a specific range of memory addresses, and it can only access the addresses in that range. No process is allowed to access a memory location outside its range. So this range of memory locations allocated to a process is called its address space. Now this address space is denoted in terms of two quantities, the base and the limit. So base is the first memory location corresponding to that process and its address space. Limit is the size of that process's address space. So every process which is currently occupying your system's memory has a base and a limit. The base is the first memory location corresponding to that particular process, and the limit represents the size of memory or the number of locations allocated. So let's take a closer look at the diagram on screen. If you see this figure, we have multiple processes occupying multiple locations in the memory. We'll take a look at this particular process. The base is at location 300040, which means the first memory location this process is allowed to access is 300040. It cannot access 300039, 300038 or anything less than that up to 0. So the legal memory addresses which this process is allowed to access begin from 300040, and there is some limit. So base plus limit goes to 420940. That is the, so 420939 is the last legal address which this process is allowed to access. Again, 420940 will be the base for the next process, and so on. So to quickly recap what base and limit mean, base is the starting address of any process's address space, and the limit is the size. So for example, these are quite hefty numbers. Let's talk in terms of smaller numbers. If I say a process P1 has memory allocated from 5 to 14, it means the base is 5, memory location 5 is the first address, and the size of the address space is 10 units, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that is base and limit. So base plus limit 15 becomes the starting address for the next process. So this process is allowed to access any location between base and base plus limit, base included, base plus limit excluded, right? So that is what this line here says. The process address space belongs to the set of all memory locations starting from base up to base plus limit, where base is allowed to you, base plus limit is not. So going back to our 5 and 10 example, base 5, limit 10. So the address space goes from 5 up to 15, 5 included, 15 not included, which means 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14, right? So and the point here is that no process should be allowed to access a memory location outside its address space, right? So how do we check that? So when a process is inside the CPU, so this part of things you are familiar with from your computer organization course. A process is loaded by means of using different registers. There is the program counter, there is the instruction register, there are buses, there's an entire fetch, decode, execute, write cycle which happens, which we went through during when we were learning computer organization. So as part of that cycle, when that process wants to access a memory location, when it sends out a request to the memory, what the CPU will first do is check whether the location this process wants to access is part of this process's address space or not. So how does that check happen? Let's take a closer look at this picture here. So it will first check whether the address you are asking for is greater than equal to base. If not, you will raise an error. If yes, it is greater than equal to base, it should be less than base plus limit. Again, if yes, go access the memory. If there is a violation over here, again raise an error, which is exactly what we saw here, right? Should be between base and base plus limit, base included, base plus limit not included. That's why there's a greater than equal to here and a strictly less than here. So the key takeaway from here is we have an address space. The first address is denoted by base, the size is denoted by limit, and the address space belongs to base, base plus limit, the former included, the latter not included. So when a process requests to access a memory location, it could be a request to read or a request to write. The CPU will first check whether this memory location lies within the address space for this process. This is the mechanism by which that checking happens, and if yes, it will be allowed to access the memory and do whatever. If not, a trap or an error condition is raised.